Hello my dear students, today we are going to discuss divisibility by the given numbers. That is, if a number is divisible by any of these numbers, leaving the remainder 0. Divisibility is useful in reducing the fractions into standard forms, in problems involving profit loss, and in prime factorization. First, let us see if the given number is divisible by 2. So, all the even numbers like 4, 10, 126, 2456, these are all even numbers. So, all the even numbers are divisible by 2. Now, let us take a number 936. This is an even number divisible by 2. But is it divisible by 3? To identify divisibility by 3, we have to add the individual digits. 9 plus 3 plus 6 gives us 18. 18 divided by 3 is 6, leaving the remainder 0. That is why this number 936 is divisible by 3. Now let's take a bigger number, 9,96,354. Let us see if this is divisible by 3. So the procedure remains the same. First, let us add all these numbers. 9 plus 9 plus 6 plus 3 plus 5 plus 4 gives us 36. Is 36 divisible by 3? Again, if this is a bigger number, apply the same thing. 3 plus 6 is equal to 9. 9 is divisible by 3. That is why this number 9,96,354 is divisible by 3. Now let us see the divisibility by 4. So, we know that the number 4 is divisible by 2. That means if a number is divisible by 4, then that is also divisible by 2. That means it has to be an even number. Let's take a number 86,752. Now, in case of 4, we don't just see the last number, we see the last 2 digits. What does it give? Let's see if 52 is divisible by 4. 4 1s are 4, 4 3s are 12. So, 4 13s are 52 is fully divisible by 4. That is why this entire number is divisible by 4. Let us confirm it by finding the proper quotient. 4 2s are 8. 4 1s are 4. 4 6s are 24. 3 35. 4 8s are 32. I have 3 here. And this 2 comes. 4 8s are 32, 32, 0. So, when I divide 86,752, I get the quotient 21,688 with the remainder 0. A tip for all the students is, if you are given a theory or a pre-made solution, then you should accept it only after confirming it yourself. You need to ask why or how did we arrive at that solution. Let's see divisibility by 5. It is very easy to identify numbers that are divisible by 5. The numbers that end with either 0 or 5 are all divisible by 5. So here this number is ending with 5 and this number is ending with 0. All these numbers are divisible by 5. Now let us see the divisibility by 6. we know that 6 is equal to 2 into 3. So, all the numbers that are the multiples of 6 should also be the multiples of 2 and 3. That means if a number has to be divisible by 6, it has to be divisible by 2 as well as 3. So, we apply the criteria of both 2 and 3 to find out if the number is divisible by 6. Let's take a number 2547. Is this divisible by 6? First thing, let's see if it is divisible by 2 and then see if it is divisible by 3. Clearly, we see that the last number is 7. That is not an even number. That is why this number is not divisible by 2. That is why this is not divisible by 6 also. Now let's take the same number in a different form. Let's take this as 74. If this number is divisible by 6, the last digit is 4, indicating that this entire number is an even number. That is why divisible by 2 criteria is solved. The next thing is to see if it is divisible by 3. Let's add the digits. 2 plus 5 plus 7 plus 4. 7, 7, 14 plus 4 is 18. 18, 1 plus 8, 9, or 18 divided by 3 is 6. So, 2574 is divisible by 3, divisible by 2. That is why this entire number is divisible by 6. Let's see divisibility by 7. This involves little longer steps. Let us take a number 7714 and see if this is divisible by 7. To find if the number is divisible by 7, we need to take the last digit of the number and double it. Means we have to take the last digit and multiply it by 2. We get 8. And take the rest of the numbers. We are left with 771 and subtract this 8 from it. So we have 3, 6, 7 here. Now for this number, we have to apply the same procedure, that is to take the last digit, multiply it by 2, we get 6, take the rest of the numbers, 76, and subtract that number, we get 70. We know that 70 divided by 7 is 10 because 7 tens are 70. That means this entire number 7714 is divisible by 7. Can we confirm it ourselves by dividing and finding the quotient? Now we are seeing the divisibility by 8. So again the same thing, 8 is a multiple of 4 and 2. That is why the number divisible by 8 is also divisible by 4 and also divisible by 2. That means the number has to be even to be divisible by 8. Now let's take a number 68,152 and see if this is divisible by 8. So to see the divisibility by 8, we take the last 3 digits. For 2, we take the last 1 digit and see if it is even. For 4, we take the last 2 digits and see if it is divisible by 4. And for 8, we take the last 3 digits and see if that is divisible by 8. So this becomes 152 divided by 8. 8 ones are 8. 72. 8 nines are 72, leaving the remainder 0. That is why this entire number is divisible by 8. Let us confirm it. This number 68,152 is fully divisible by 8. Now the next number is divisibility by 9. It's the same procedure as 3. Add all the digits and see if the number is divisible by 9. Let me take the number 963 and see if it is divisible by 9. So this is 9 plus 6 plus 3, which gives 18. 18 divided by 9 is 2. That means 963 is divisible by 9. Let me attach a number to it, say 3. Let's see if this is divisible by 9. We see that 9 plus 6 plus 3 plus 3, when I do, this becomes 21. This 21 is divisible by 3 but not divisible by 9. That is why 9633 is not divisible by 9 but divisible by 3. The easiest of all these is divisibility by 10. Any number ending with 0 is divisible by 10. I can write any number 8650 or add or something like 5250. All these numbers are divisible by 10. The last in our list is the number 11. Let's see if the given number is divisible by 11. Let's take a number 3,32,684. Let us see if this number is divisible by 11. First thing we have to do is identify the odd places and identify the even places. Let us take the digits in odd places, that is 4, 6 and 3 odd, and the digits in even places 8, 2 and we have to clearly mention sum of digits in odd places is equal to 4 plus 6 plus 3, that is 13, and similar way sum of digits in even places, that is 8 plus 2 plus 3, that is also 13. Now we have to subtract the sum of digits in even places from the sum of digits in odd places. Here it is 13 minus this 13 odd, even, and we get 0. 0 is divisible by 11. That is why this entire number is divisible by 11. Let's take another example. 70,884 and see if this is divisible by 11. So the digits in odd places are 4, 8 and 7, and digits in even places are 8 and 0. Now let's find the sum of digits in odd places, that is 4 plus 8 plus 7, 12 plus 7 is 19, and sum of digits in even places, that is 8 plus 0, that is 8. Now let us subtract the sum of digits in even places from the sum of digits in odd places, that is 19 minus 8, which gives us 11. 11 is divisible by 11, that is why this entire number 70,884 is divisible by 11. We have seen the divisibility of a given number by all these numbers. I am going to give few problems at the end of the video. Solve it and compare your answers with the answers given in the description box. Love maths.